Hello, my name is Armando Ramos, and this is Group Two's presentation for Human Systems Engineering 325 Human Computer Interaction. Final project. Our final project, we are doing a deep dive on signal detection theory. We are constantly filtering information from our environment, and understanding how we detect meaningful signals helps us design better technology, makes safer decisions, and even saves lives. Signal detection theory is a psychological framework that helps explain how we make decisions when we're trying to detect a signal in a noisy environment. It's not just about whether the signal is there, it's about how we interpret what we see. Signal detection theory emerged in the 1950s as a framework to understand how observers discern between meaningful signals and background noise. Initially developed in the context of radar and communications during World War II, signal detection theory provided a mathematical approach to decision making under uncertainty. In 1954, Peterson, Birdsall, and Fox laid the theoretical groundwork for signal detection theory, focusing on its applications in engineering and signal processing. That same year, psychologists Wilson P. Tanner, David M. Green, and John A. Sweats extended these concepts to human perception, exploring how individuals detect signals amidst noise and various sensory modalities. The seminal work for signal detection theory and psychophysics by Green and Sweats in 1966 further solidified signal detection's role in psychology, particularly in psychophysics. This work introduced key concepts such as receiver operator characteristics, ROC curve, enabling researchers to separate an observer's sensitivity to a signal from the decision criterion or bias. Over time, signal detection has become instrumental in various fields, including psychology, neuroscience, and medical diagnostics, providing insight into human decision-making process and the factors influencing perceptual judgments.
Our senses pick up signals like light, sound, and touch and send them to the brain, but they're not perfect. We sometimes miss things or notice stuff that isn't really there. Signal detection theory helps explain how we make those decisions when the input is unclear. After our senses pick something up, the signals get sent through our nervous system to the brain. The brain then figures out what we're actually seeing, hearing, or feeling. So it's not just about getting the info, it's about how our brain makes sense of it and turns it into something that we understand. Understanding what senses and stimuli are is key to signal detection theory. The whole model depends on how well a person can detect a stimulus using their senses, especially when there's noise or distractions, making it harder to tell what's real and what isn't.
Perception is how we organize and interpret sensory input, but we all perceive things differently. For example, one person might see a vase in the image on the right, while another sees two faces. These differences can lead to misinterpretation. In signal detection, a hit happens when a signal is present and noticed, while a miss means it's there but goes undetected. Whether it's a hit or miss depends on how the signal is perceived. Many factors affect perception, even with perfect senses. According to the signal detection theory, detection depends on sensitivity, which is the ability to tell a signal from noise. External influences such as bright lights or mood, stress, and fatigue can act as noise and lower the individual's sensitivity, which increases the likelihood of misses. As mentioned earlier, noise lowers sensitivity and makes detection harder. Noise is anything that interferes with spotting a signal. In today's world, constant emails, ads, and notifications create a noisy environment. This floods us with distractions that our attention must constantly filter out. If an individual is not as experienced with filtering out unwanted stimuli, they are more likely to miss signals.
To study signal detection theory, researchers design experiments where a weak stimulus, like a soft beep or dim flash, is randomly presented. Participants have to decide, was it there or not? These setups help isolate true sensitivity from decision bias, and they lay the foundation for understanding perception under uncertainty. SDT breaks responses into four types. A hit means you correctly detected a signal. A miss is when you didn't notice a signal that was there. A false alarm means you thought you saw or heard something that wasn't real. And a correct rejection is when you accurately ignored noise. This matrix helps explain not just accuracy, but decision strategies. Modern SDT research applies to critical decision-making tasks. In medicine, radiologists use it to detect signs of disease. In aviation, it helps air traffic controllers interpret radar data. These roles require people to filter out noise, manage uncertainty, and act fast, which makes SDT vital for designing safer systems.
Here is an example. Every second your brain filters out signal like a radar, a pedestrian signal, a shadow noise. Signal detection theory reveals our balancing act, brakes, false alarm, or risk missing thread. Veteran drivers excel because they have optimized this mental threshold. Working hard for a paper bag, that's a classic false alarm. Ignoring a stalled car, that's a deadly miss. Factor like rain or phone use can spike this error, causing our nerve to go haywire. 94% crashes involve this exact judgment error. The mental limit between react and ignore isn't just theoretical, it's the difference between safe arrival and catastrophe. Here is how to rectify. Scan 12 seconds ahead. That's 4 city blocks. Verbalize the hazard like cycling tuning to sharpen focus. Text helps, but brain remains your ultimate collision sensor. Train drivers spot threats 2 seconds faster. Next drive, play spot the hazard. You will be tuning the most advanced safety system, your trained mind.
Signal detection theory is used in high-risk places such as airports, where TSA need to identify possible risks and differentiate them from false alarms. The goal is to be able to identify and check suspicious individuals without overwhelming amounts of false alarms. They use X-ray screening, automated threat detection systems, and trained behavioral detection officers to improve their hit rate. In the medical field, signal detection theory is used to help doctors and radiologists distinguish between signs of disease, which are signals, from ambiguous findings, which are noise. For example, while reading an MRI, a doctor must decide if a shadow is a harmless tissue or cancerous. The goal is to detect things early while also avoiding any unnecessary procedures. Signal detection theory is also used in cybersecurity. It's used to program software as well as train users to avoid phishing emails or malware. A well-calibrated system correctly identifies threats while minimizing false alarms and misses. Thank you for listening to our presentation. I hope you enjoyed, and here are our sources.